Now we're going to do a problem workthrough for problem 113 in lesson 4.2, solving for the impulse using a numerical calculation method. Now, in this problem, we have our first compound formula where the impulse, J, is equal to mass times the change in velocity, which is also equal to force multiplied by time. So that means that the impulse is equal to mass times the change in velocity, but impulse is also equal to force multiplied by time. But we could also do this relationship, mass and change in velocity multiplied or equals force times time. So there's a lot of different relationships that we can do depending on what we have in the problem. As always, start with the laundry list. We have a 32-gram object that is traveling at a velocity of 38 meters per second. And this key is also important. What impulse is needed to stop the object? So that means that we have a mass, an initial velocity, and a final velocity, and we are looking for impulse. So impulses are unknown, right? It says right there what impulse is needed. Now, the object is going to stop. So that means that the final velocity is 0 meters per second, whereas the initial velocity is 38 meters per second. And our mass is given as 32 grams. But we have a problem with that because nothing that we do in physics uses grams. So we automatically have to change this value from 32 grams into kilograms. In order to do that, we divide this by 1,000, so we get 0. Remember, dividing by 1,000 just means we move our decimal point 3 spaces to the left. So tens, hundreds, one more space would be thousands, so 0.32 kilograms. Now with that, if we need to find the impulse, and we have mass, and an initial and a final velocity, we know that impulse equals mass times the change in velocity, whereas the change in velocity is final minus initial. Remember, the change in velocity is always the final minus the initial. So when we substitute in, we have 0.032 kilograms multiplied by 0 minus 38 meters per second. So we have 0.032 multiplied by negative 38. That gives us a grand total of negative 1.22. And the unit for impulse is going to be Newton seconds. So NS. And that is our answer for this problem.